Assalamualaikum and welcome to my video presentation. First of all, I would like to express my gratitude to all watching my video presentation, especially to the chairman, to all panel, professor, doctor, ladies and gentlemen. Today I'm going to present my presentation entitled Experimental Onion Pull-Out Test of Shear Thickening Fluid Natural Fiber.
Okay, let's proceed to introduction. Usually, the woven fabric is made up from natural fiber and synthetic fiber. In engineering, the researcher is commonly use synthetic fiber due to its advantage, such as high strength, high modulus, and also low density. In this research, the natural and synthetic fiber are being tested to evaluate the performance in terms of pull-out testing. Okay, the type of fiber that have been used, which is pineapple, jute, basalt, and also glass fiber. Okay, there are many researchers are studied to replace synthetic fiber to natural fiber in composite due to its environment issue and also to reduce cost. Although synthetic fiber meets the mechanical properties. Okay, as we know that although that natural fiber is low cost, recyclable and biodegradable, but it's also lower strength, especially in impact strength. Okay, for the solution is implementation of STF. By implementation of STF can enhance fabric strength performance of the fabric. Okay, for shear thickening fluid. Shear thickening fluid are non-Newtonian fluid where viscosity is dependent on shear rate or applied stress. A fluid that behaves like a solid when it experiences an impact at high shear rate. Objective of the research is to investigate the effect of STF towards fabric through pull-out testing. Besides, to evaluate the inter-yarn friction through different volume ratio of STF as a surface treatment. Okay, for scope, STF material is made up from fumed silica, polyethylene glycol 400, ethanol 95% concentration. STF composition is 15 and 20 weight percentage. Fabric material is from pineapple fabric, jute fabric, basalt fabric, and glass fabric. Testing is yarn pull-out test. Okay, for literature review. Based on the previous study, many researchers investigate the implementation of STF with Kevlar to analyze the ballistic impact. Okay. For natural fiber, the investigation are more common in terms of reinforcement of epoxy composite, and they are finding that the treatment enhance the property of this fabric. Let's move to methodology. This is project flowchart. Okay, STF fabric implementation process. STF was prepared by dissipation of 15 and 20 weight percentage. The fumed silica particles were first dispersed in ethanol and then blended with PEG. The mixing process was run for 3 hours until a homogeneous and stable suspension was achieved. Ethanol was later removed through the evaporation process at 80 degrees in the oven. Okay, next, STF need to dilute with ethanol due to high viscosity of the STF and need to mechanical stir for around 10 minutes, and then soaking with the fabric. After done soaking for 10 minutes, the fabric need to dry in the oven to remove the ethanol. After that, the final product STF fabric will achieve. For yarn pull-out test, the dimension of sample required to set up like this before tests are conducted. Test was conducted on universal testing machine Shimatsu. The fabric was clamped in between of yarn pull-out jig, and only single yarn in the middle was gripped and pull out at a constant rate of 50 mm per minute. Okay, for the result, the force can be divided into two forms, that are static force and dynamic force. Static force refer to the amount of force required to overcome the force of the static yarn when the yarn start to shift after being pulled. As the free end of the yarn start slipping through the weave of the fabric, the static force changes to dynamic force and progressively decrease. For knit fabric, each fabric show the different of maximum friction force. Okay, as we can see, the maximum force of pineapple's fiber are the highest with 16.2 Newton among the other, which is jute 5.19 Newton, basalt 2.54 Newton, and glass fiber 0.76 Newton. The comparison between STF fabric 15 weight percentage and 20 weight percentage. Okay, the result demonstrate that the fabric composite is higher maximum friction force compared to knit fabric, and it has been proved that the major effect of STF in impregnated fabric will enhance the fabric strength, which is increase the friction force between the yarn in the fabric. Okay, in terms of particle fraction, fabric composite of higher silica content, which is 20 weight percentage, display higher pull-out force compared to the lower silica content. The maximum force of fiber increase along with the increasing in volume ratio of STF. Okay, for pineapple fiber is classification as natural fiber, which is made from pineapple leaf and have a rough surface of fabric compared to other type of fiber. There are significant difference in terms of maximum force between knit fabric and STF treatment, about 2 times as much as knit fabric. Okay, the percentage increase of pull-out force compared to knit fabric for 15 weight percentage is 87.95%. Okay, for 20% weight percentage is 117.72%. For jute fabric is a type of textile fiber made from jute plants. Jute is a relatively rough fiber and have a good durability. The trend of force displacement curve for the STF jute fiber is similar to other curve, and the difference is that the linear limit force of each sample. As we can see here, the percentage increase for 15% weight percentage is 105.4%, and for jute 20% weight percentage is 222.60%. Okay, for basalt, in terms of maximum static force, this force is steadily increased to reach its maximum value and no slippage occur in the fabric. Knit basalt gives the highest value maximum static force, but when STF impregnating the fabric, knit fabric produce the lowest dynamic force compared to the STF impregnated fabric. The percentage decrease of pull-out force is for 15% weight percentage is 25.98%. For basalt, 20% weight percentage is 20.47%. Although the knit fabric have the higher maximum force, but for dynamic force for both STF basalt is higher than knit. Okay, for glass fiber, the difference of maximum force between fabric is quite small, but still have an improvement compared to the knit fabric. The percentage increase is for 15% weight percentage is 13.16%. For 20% weight percentage is 34.21 weight percentage. This slide is about comparison of maximum static and dynamic force of the previous study. Okay, for experimentation of the previous study, the sample that were tested is Kevlar fabric. The STF Kevlar were fabricated with two different methods, which is A and B. The comparison will be done by comparing STF Kevlar with method A, which is the same method in this experimentation. Okay, comparison of maximum static and dynamic force between fabric and previous study. The results show that the STF pineapple composite is slightly different in terms of maximum friction force. This type of natural fiber have higher maximum force compared to the STF Kevlar in both composition of STF. However, for maximum dynamic force in STF pineapple composite is lower than STF Kevlar in both of composition. Okay, for conclusion, based on the result and discussion, the maximum friction force of the sample as an overall is increased after the fabric were treated with STF compared to knit fabric. Besides, the maximum of friction force are increasing along with the increase of volume ratio in STF impregnating fabric. Okay, for recommendation, diversifying the testing method. For example, the sample can be testing in terms of stack resistance, also ballistic test to analyze the strength of the natural fiber as reinforcement composite. Furthermore, diversifying the parameter of STF in the experiment can improve the rheology behavior, which will enhance the strength of treated fabric. Okay, that's all for me. Thank you.